Good day everybody. This is the last but one question that was asked at MIT Integration B Finals of 2023. We expected to integrate this quantity 10 raised to the power of 20 times integral 2 to infinity x to the power of 9 times dx over x raised to the power of 20 negative 48x raised to the power of 10 positive 575. Now I have x raised to the power of 9 and that is the clue that I require, because over here I got x to the power of 20 and I know that I can rewrite x power 20 as x raised to the power of 10, the entire quantity raised to the power of 2. So that would help me with the substitution. So foremost, what I wish to do is I would like to multiply the numerator by 10 and divide by 10. So multiplying the numerator by 10 and the denominator by 10. That's exactly what I'm doing. Now I'm going to rewrite x raised to the power of 20 as, let me write it in this fashion, x raised to the power of 10 the whole raised to the power of 2 negative 48 x raised to the power of 10 positive 575. So let me make the substitution. Let x raised to the power of 10 be equal to some t. If I were to differentiate with respect to x, we get 10 times, or I should say differentiating both sides, that's the best word to say, because on the left it's going to be dx and on the right will be dt. So the best way to say is differentiating both sides, we get, so differential of x power 10 is going to be 10 times x to the power of 10 negative 1 times differential of x is going to be dx, differentiation of t is going to give me dt. This can be rewritten as 10 times x raised to the power of 9 times dx is equal to dt. So this can be rewritten as, if I were to push this 10 to the numerator, this is going to be 10 raised to the power of 20 times 10 raised to the power of negative 1 followed by integral sign 10 times x raised to the power of 9 times dx. This is what is going to be dt. So let me just place the dt there, divided by x to the power of 10 as a substitution as t, place that, raise it to the power of 2 followed by negative 48 t positive 575. Now this can be rewritten as 20 added to the negative 1, that's going to be 19. So you got 10 raised to the power of 19 integral. Now I am not transferred the limits. Let me do that. So when over here it's 2 to infinity, right? So when x is equal to 2, what is the value of t? T is equal to 2 raised to the power of 10, that's going to be 1024. Now when x is equal to infinity, t is equal to infinity. Raised to the power of any quantity will give me infinity. So the values are 1024, over here upper limit is going to be infinity, and you got dt over, now t squared negative 48t positive 575. I would like to write it in this fashion, t squared negative 48t positive 576 negative 1. Now you might be wondering, why did I split it in this fashion? Within a minute you will know why. So this is 10 raised to the power of 19 times integral 1024 to infinity dt over. Now I would like to rewrite this quantity as a perfect square. Is it okay if I were to write this as t negative 24 raised to the power of 2? When I expand, I get t squared negative 48t, 24 squared gives me 576. That's the reason I have written 575 as 576 negative 1 followed by negative 1. So this is what I've got. Now what I wish to do is I would like to make another substitution. Let t negative 24 be equal to some p. So dt is equal to dp. So this is equal to 10 raised to the power of 19. I'm not going to change the limits as yet. In place of dt, it's dp. In place of t negative 24, it's p. This has got a power 2 followed by negative 1. Now, when t is equal to 1024, what happens to p? P is equal to 1024 minus 24, which is nothing but 1000. Followed by, when t is equal to infinity, what is the value of p? P is going to be, if you substitute infinity, p is going to be infinity, right? So this is going to be 1000 to infinity. Now I would like to split p squared negative 1 as follows. So this is equal to 10 raised to the power of 19 times the integral 1000 to infinity dp p squared negative 1. Now a squared negative b squared is a negative b times a positive b. So this is going to be p negative 1 times p positive 1. Now if I were to use partial fractions, let me just write this in this fashion. Consider 1 over p negative 1 times p positive 1 equal to a over p negative 1 positive b over p positive 1. If you cross multiply, you get 1 is equal to a times p positive 1 positive b times p negative 1. If you were to take p to be equal to 1, this vanishes. This is going to be 1 positive 1. So 2 times a is equal to 1. Therefore, the value of a is 1 over 2. Right? And if I were to take p is equal to negative 1, this will vanish. This is going to be negative 2 times b is equal to 1. Therefore, b is equal to negative 1 over 2. So I've got the value of a and b. So therefore 10 power 19 times integral 1000 to infinity, this quantity is replaced with the partial fraction quantity. So in place of a, I got 1 over 2 divided by p negative 1. In place of b, I got negative 1 over 2. If I were to substitute, I can take the negative sign out. So this is going to be 1 over 2 divided by p positive 1 times dp. Now this can be split and rewritten as follows. So 10 raised to the power of 19 and integral, I can take 1 over 2 out. If I take 1 over 2 out, this is going to be divided by 2, right? I can take 1 over 2 out. So this is going to be integral dp divided by p negative 1 negative integral dp divided by p positive 1. The limits are 1000 to infinity. So this would give me ln modulus of p negative 1 negative ln modulus of p positive 1. This is what I would be getting. And this is equal to, of course, I need to substitute the limits. The limits are 1000 to infinity. Over here, I get 10 raised to the power of 19 divided by 2. Now, we know a formula, ln of a negative ln of b is ln of a over b. I can write it like that by logarithmic formulae. So this is 10 raised to the power of 19 divided by 2 times ln of p negative 1 divided by p positive 1. So you got the modulus there. And the limits are 1000 to infinity. Now this can be further rewritten as 10 raised to the power of 19 divided by 2 ln of p negative 1 over p positive 1. The limits are 1000 to infinity. Now we have to exercise some caution because this particular quantity is tending towards infinity. Right, for p tending to infinity, we need to know what happened to this particular series, right? So what I'm going to do is I'm going to be performing a few manipulations. So because I need to get rid of this quantity for p tending to infinity, because we cannot have infinity. If we were to have infinity, it would be a divergent series, so we wouldn't be able to arrive at a value. So to arrive at the value, what I wish to do is I would like to take p out If we were to take p out, there's going to be 1 negative 1 over p divided by, I take p out, it's going to be p of 1 positive 1 over p, right? The limits, this is with the limit tending to infinity, right? The limits are actually tending to infinity. So what I will do is I will just have this column for p tending to infinity. P is going towards infinity. So since p is tending towards infinity, this is for the upper limit minus the lower limit. So the lower limit is going to be ln of 1000 minus 1 divided by 1000 plus 1 and square parenthesis, right? Now when p tends to infinity for this part, okay, I'm going to apply p tending to infinity. As p tends to infinity for this part, 1 over p will tend to 0. So this is going to be 0. In fact, this p and this p gets cancelled. That's the first step. And then as p tending to infinity, 1 over p tends to 0. So this tends to 0, this tends to 0. You got 1 over 1, which is ln 1, right? And that one will perish. So this entire thing will vanish, right? So what is left is this quantity. So let me write that quantity here. So this is equal to 10 raised to the power of 19 over 2, negative sign, I can place the negative sign over here, times ln of 1000 minus 1 divided by 1000 plus 1. This is what I've got. Now a times ln b is equal to ln b raised to the power of a, right? So I can push this negative sign over here. This is equal to 10 raised to the power of 19 divided by 2 ln of 1000 negative 1 divided by 1000 plus 1 raised to the power of negative 1, right? Now suppose you have 2 raised to the power of negative 1. What is that? That's nothing but 1 over 2. So you can flip this quantity, you can flip it. So if you were to flip it and write this quantity, I want to finish it off here. So this is going to be equal to 10 raised to the power of 19 divided by 2. If you were to flip it, this is going to be ln of 1000 plus 1. You can write 1000 as 10 power 3, right? It's okay, but I'm going to write it as 1000 negative 1. So this is the solution. 10 raised to the power of 19 divided by 2 times ln of 1000 positive 1 divided by 1000 negative 1. Thank you everybody. Enjoy your day.